Hi, let's take a look at how to use the micrometer pictured here to make high-resolution measurements of thickness. I've used the term resolution, and I'd also like to address the term accuracy. Please don't confuse them. Resolution is a description of how finely divided the scale on a measurement device is. For example, most U.S. car odometers resolve distance measurements to the nearest 1/10 of a mile. A typical household yardstick, like the one you see here, resolves them to the nearest 1/8 of an inch. And the micrometer that you see pictured above resolves them to the nearest 1/1000th of an inch. So what about accuracy? Well, accuracy is a description of how closely a given measurement represents the actual value. It's the error in the measurement. An error can creep into a measurement for a lot of reasons. It can be due to carelessness of the person making a measurement, due to device calibration or lack thereof, due to rounding errors in a reading that comes out between resolvable values, and for other reasons. As an example, let's take a look at a measurement using the yardstick. You can see that I've laid a piece of cardstock down at the edge of the ruler. It's a little bit sloppily placed by the 20-inch mark, so we've got a little bit of error right there. And then you can see that the other edge falls between two measurement values, two of the marked values on the scale. So you could round down to the nearest mark, making the measurement 1.5 inches, or you could round up to the next mark, making it 1 5/8 inches. Either one would be acceptable. You can also interpolate between the two marks and call this measurement 1 9/16. But no matter which one you choose, it's still only an approximation, and you don't even know if the marks on the ruler are accurately placed to begin with. Okay, so what about the micrometer? Let's check it out. If you pick it up and take a look at the other side, you can see that it has two scales. It has two knurled knobs and a rotating barrel. Those two knurled knobs rotate the barrel the same either way, but you should always close the jaws using the outer smaller one because it's ratcheted to prevent an overexertion of torque on the thing. The stationary shaft is marked in 1/10 of an inch increments. The rotating shaft is marked in 1/1000th of an inch increments, and we know that because every 1/10 of an inch, it takes 4 complete rotations to get from one marked 1/10 of an inch to the next. So from 4 to 5 took 4 rotations, 25 marks per rotation, that's 100, which is 0.100 inches. So let's take a look at how we can use this micrometer to measure the thickness of this €2 coin. I'm going to place it between the jaws, and then I'm going to go over here and turn the knob until the jaw closes on the coin. There's the ratchet telling me that I've tightened it down enough to get an accurate measurement. Now if you take a look at the measurement scale on the stationary shaft, you can see that we are just over 3/4 of the way between the 0 and the 1. So that's already 0.075, and then the rotating barrel has gone 14 thousandths beyond that. So 0.075 plus 14 is 0.8089 inches. So that €2 coin is 89 1/1000ths of an inch thick.